Hi, everyone, and welcome to one of today's last sessions on Unreal Fest. Thank you for coming. And if you are here, it's because you are interested in character customization. If not, you're lucky because you can just go home. But let me introduce myself. I'm Gerard Martin. I'm one of the programmers at Mutable at Epic Games. So let's start. For today's agenda, we have what's Mutable, Mutable hands-on, in which we will see a brief character customization example, features, in which we will see an overview of what Mutable can do, a brief introduction on how Mutable works under the hood, real-world case studies, common pitfalls, and finally, a Q&A. So what's Mutable? Mutable is a tool for creating mesh and texture customization systems. It is not a customization system by itself. For example, with Mutable, you can create a character customization system, which then players can use to create their own characters in-game. Keep in mind that you are not limited to only characters. You can also create any kind of customization objects. For example, vehicles and weapons. Mutable not only works on editor, where developers specify what users will be able to customize, but also works at runtime, where skeletal meshes and textures are generated based on what players have selected. And last but not least, keep in mind that Mutable is still in beta, so expect some issues. We'll be out of beta soonish. To better understand what's Mutable, I also want to put some emphasis on what it's not. Mutable does not provide any assets, so you need to provide your own. Although it has features to ease the automatic creation of UIs, Mutable is not a UI tool. It is not MetaHuman Creator, but you can still use MetaHuman assets with it. And lastly, it is not a drop-in replacement for skeletal meshes. It has a runtime overhead. This overhead is only during the generation of those skeletal meshes. Once they are generated, the overhead is gone. With Mutable, you can create customizable systems and avoid the combinatorial explosion of manually making each part compatible with all the others. For example, with Mutable, when you create a new jacket, you don't need to make it fit with all existing shirts. You leverage Mutable to make it fit. Mutable can also be used for optimizing existing Unreal Engine customization systems. With it, you can merge components, draw calls, and textures, and not pay the price of splitting characters into multiple modular parts. Finally, Mutable can also be used as a runtime mesh and texture editing tool. Although Mutable is in beta, it has already been battle tested in many projects such as PUBG for the player customization, Crime Boss Rocky City for baking NPCs for crowds, Lords of the Fallen for the player customization, and of course in Fortnite, first on Alias and Keeper characters, later on all LEGO minifigs and some creatures like cows and sheep, on all Fortnite cars, which include sport cars and SUVs, and finally in Kicks, to adapt choose to any Fortnite character. And also not to forget the upcoming Dune Awakening. So now that we've seen what Mutable does, we're going to create a simple character customization. Here is an overview of what we're going to do. First, we will take the skeletal meshes and texture. With those, we're going to create a new customizable object that will specify how to combine them. Next, we will instantiate the customizable object, specifying which particular customization do we want. And finally, we'll drop the instance customizable object into the level to create an in-game actor. So let's begin. First, we're going to create a new customizable object. Our customizable object has a graph which defines all the possible customizations an object will have. The character we're going to create will be composed of a single skeletal mesh component. We're going to specify it by adding a new skeletal mesh component node. Then we're going to add the body geometry as a skeletal mesh section. And in addition to the body, we're also going to add the shirt geometry as a second skeletal mesh section. Finally, we're going to add a decal texture to the shirt. So far, what we have created is a static character with no customization. Now we're going to add some customization to it. First, we're going to replace the decal texture with a switch. The switch will be controlled by an enum parameter that the user will be able to change. Similar to the decal, we're also going to add a second switch, but this time to the shared geometry. The user will be able to control this second switch using a different parameter. Optionally, we can replace the switches with data tables, so we can easily add more content without having to constantly modify the graph. A data table is basically equivalent to a switch. It internally creates a switch entry for each row in the table. And finally, once the customizable object is set up, we can right-click on the customizable object, create a new instance, and from there, simply drag and drop it to the level to create a new actor. Once we have an instance, we can change its parameters to create new customizations. Simply reference the instance in a blueprint, change all the parameters you want, and call the update skeletal mesh async function. Notice that this function is called async. This means that the resulting skeletal mesh will be not generated instantly. Otherwise, you can change the parameters using C++. Mutable has a one-to-one parity with both blueprints and C++ APIs. In there, you can see the results of changing the decal parameter. Changing the parameter generates a new skeletal mesh that gets automatically applied to all actors referencing the instance. In addition to switching, Mutable also allows you to perform mesh operations such as clipping geometry. For example, you can clip the geometry using simple clip volumes. You can clip vertices by selecting them on the UV layout, or clipping and morphing the remaining geometry. This is especially useful when you want to fit a punch leg inside a wood. These clipping operations can be conditional. For example, when you keep a shirt, you can also, at the same time, remove the underlying geometry. Also Mutable, you can edit geometry by reshaping it based on external shapes, baking morph directly into final skeletal meshes, and simply doing a linear transform on the geometry. Again, these operations can be conditional. So for example, when applying the pants and the jacket at the same time, you can reshape the jacket to avoid clipping issues. So with Mutable, you can not only edit meshes, but you can also edit textures. Some operations that you can perform are projections, where you can project textures onto others without the GPU cost, layering, where you can blend textures using different blend modes, and texture packing. This is done automatically when merging skeletal mesh sections. Mutable not only supports linear projections, but it also supports wrapping projections, which are useful when the projection surfaces are non-planar, and cylindrical projections. In addition to mesh and texture operations, Mutable also supports optimizations such as merging skeletal mesh components into a single one, merging skeletal mesh sections with automatic texture packing as we just saw, and baking customizable object instances into normal static skeletal meshes and textures. But that's not all. With Mutable, you can also edit the physical simulation meshes of clothing, merge the skeletons with a caveat that they must have the same root hierarchy, and add metadata to the graph to create automatically generated data-driven UIs. And finally, Mutable also has performance tools and to debug and optimize your customizable objects. And last but not least, Mutable has been integrated into other engine systems such as animation blueprints, control rig, the human DNA, and glooms. So far, we've seen what Mutable can do, but how it works. As we saw in the previous slides, developers define a set of operations through the customizable object graph. Then the graph, meshes, and textures get compiled, and during this process, a set of optimizations are applied. The final optimized graph, texture, and meshes get transformed into runtime virtual machine code, which is fast and efficient to be executed during gameplay. During the completion is where all the magic happens. Hence why Mutable can do so much at runtime. One of the most important optimizations is identifying and caching constant code. To give a brief overview, when a branch of operations is affected by a parameter, Mutable collapses them into a single constant. This way, the number of operations performed at runtime gets largely reduced. For example, if a mesh is always clipped, the mesh will actually be stored in clip form, stripping the clipping operation done at runtime. Other optimizations that are applied during the compilations are states, where developers can lock parameters so Mutable can collapse more branches. Developers can create multiple states, each one locking different parameters, especially useful for real-time customization lockers. Deduplication, where Mutable tries to reuse as much data as possible. Reordering, where operators are reordered to do less work. And finally, Mutable can change meshes and textures to their most optimal formats for runtime. Once a customizable object is compiled, Mutable can perform runtime updates on it. A runtime update takes the parameters, the user parameters, compiled Mutable meshes and textures, and operates on them. Once update finishes, Mutable returns normal skeletal meshes and textures, which then can be used on any normal actor. Keep in mind that meshes and textures are not always loaded. Mutable only streams them in when they are necessary for the update. But compiling meshes and textures has an overhead. Mutable also allows you to not compile them into its own format and use skeletal meshes and use textures directly. This mode is called pass-through. And Mutable only allows you to switch between pass-through meshes and textures. No other operations are allowed. So moving on, we're going to see some real-world case studies. Let's start with alias and caper, both Fortnite characters. In both alias and capers, you can customize the stickers and the head accessories. Head accessories are merged during runtime. Interestingly, Mutable was chosen for being able to bake projections directly into textures. Both characters support up to 16 projections, which would have been impossible to do directly with shaders due to the sheer number of texture samplers. Next, we're going to see Fortnite kicks. Unlike alias and caper, kicks do not offer any user customization. Users can either select one pair of shoes or the other. Although there is no customization from the users, shoes are tailored per Fortnite character. A single pair of shoes must fit all existing Fortnite characters, and there are more than 2,000. Each character has data that drives the shoe transformation, allowing them to be adapted. Socks are also morphed to best fit the character legs. Finally, some characters may have 1 or 2 feet, but regardless of how many they have, it's always a single skeletal mesh component. Moving on, LEGO Fortnite minifigs. Unlike both previous examples, LEGO's minifigs do not offer any kind of customization. Players can only switch between minifigs. In this use case, Mutable is being used primarily for disk savings. Minifigs are stored disassembled, like Lego pieces, and then reassembled at runtime, allowing you to reuse many assets between them. Once again, since they are assembled at runtime, Mutable merges all pieces into a single skeletal mesh component. Finally, Mutable is also being used as a pipeline tool, since it makes it easier for artists to create new minifigs from existing pieces. This became especially important during the initial development of LEGO Fortnite. Mutable allowed artists to create hundreds of different minifigs in a time record, making sure that the project was not delayed. Since minifigs was a huge project, we've learned a few lessons with it. Due to having a one-to-one relation between minifigs and existing Fortnite characters, there was a huge amount of minifigs. This meant that the customizable object was huge. Due to its size, we had to split the customizable object to avoid a higher runtime memory cost than usual. We are always actively working to try to reduce Mutable's memory footprint. Also, due to how the graph was designed, there were some invalid parameter combinations that made some optimizations impossible. Always try to design your graph with only valid combinations in mind. And finally, the minifig customizable object was expensive, but this time due to the sheer number of texture operations. This became especially an issue with crowds, since it's not the same to generate a single expensive instance than generating dozens, especially if you don't have the CPU budget. And last, Fortnite cars. Unlike LEGO minifigs, Fortnite cars can be customized. Players can choose which car, wheel, and chassis decal they want. In this project, Mutable has been successfully used as a scaling tool. With it, You can easily add new wheels and decals to all vehicles without having to manually modify each one. In addition to players being able to customize the cars, they also get automatically customized depending on which game mode they are being used on. Being the second largest Fortnite project using Mutable, we also learned a few lessons. As in LEGO minifigs, large customizable objects were a problem, but this time due to long completion times. If a customizable object is large, it is better to split it into smaller ones, and also keep an eye on the upcoming dataless customizable object, which basically it will solve this problem. It will make compilation times constant and not dependent on how much data customizable objects have. Since cars do not perform any mesh or texture operations, they were the ideal use case for pass-through mode. Finally, try to merge as many components as possible. Instead of having 5 components, one for each wheel and the body, you can merge all components into a single one, reducing the overhead of those. So now that we're reaching the end, I want to go over the most common pitfalls. We already saw some of them. With crowds, take into account the performance. If you want to use Mutable with crowds, avoid creating expensive customizable objects without having the CPU budget. Also, consider baking them. Use pass-through whenever possible, especially if you don't need to perform any operations. Keep an eye on large customizable objects. They will have long completion times and a relatively high memory runtime cost. Design your customizable objects so to avoid invalid parameter combinations. Be aware of expensive operations. Texture operations have a much larger cost than mesh operations. Updates are asynchronous, so expect a few ticks of delay before getting the generated final skeletal meshes. And finally, avoid unnecessary customizations. If nothing has changed, simply don't request the update. So at Mutable, we are constantly improving. And we're trying, so here it's an overview of what's coming next. Macros, which will just release an experimental on 5.6, where similar to blueprint macros, you can now group nodes and reuse them. Improved streaming, just released on 5.6. This improved the overall CPU and memory cost during runtime updates. Improved pass-through meshes, where you will be able to easily change the material parameters of pass-through meshes. Dataless customizable objects, where you will be able to pass textures and skeletal meshes as parameters at runtime. Automatic actor hierarchies, where Mutable not only will be able to generate the skeletal meshes, but full actor hierarchies with different components. Throughput optimizations, where Mutable will be able to perform more updates per second, especially useful for crowds. And finally, memory optimizations. Mutable will have a lower baseline memory cost for huge customizable objects. If you want to start playing with Mutable, here are some useful links. You will have the QR codes at the end of this, and a slide on the end. I personally recommend following the tutorials and start playing with the Mutable sample. Also, keep an eye on the upcoming Mutable sample update. In it, you will be able to change the body type of the character and see how all closed pieces gets automatically adjusted. And if you want to get in touch, you can always contact the Mutable team through UDN or contact me directly with the Epic developer community. And thank you. I hope you now have a good overview of what Mutable can do. And let's move to the Q&A.